Hey, what's up, everybody? Mr. Cornell here, ready to go over one of my favorite subjects, factoring. Why is it my favorite subject? You might say because it's easy. Why do you say it's easy? Because I'm a math teacher. Of course, I'm supposed to say it's easy. I would hope I think it's easy if I have to teach it to you. But no, not any of those reasons. Why do I like factoring? Factoring is because there are steps. You follow the steps, you will get the answer. And it's not, well, you said if I follow the steps and then all of a sudden but if it looks like this, then you have to do this. Or if it looks like that, then you have to, no. Every single factoring question will follow this same process. So this is just kind of the basics. I like to call them like the first three steps for factoring, and then that could take you into some more things a little bit later on, depending on how high up in math you go. But we're just going to look at the basics of factoring and what I call the three basic steps for that. All right, so let's go through them here. So try to take some notes or something that you might be able to read along with or follow, just in case you start doing your own ones. All right, so like I said, there are three steps. So there's step one, there's step two, and then right over here, I'm going to try and finish step three. So the first step for factoring is called GCD, greatest common divisor. Some people like to call it GCF for greatest common factor. All right, it depends on who you're listening to. All right, so this first one, GCD, there are two things you're going to have to look for in common. One would be the number that's in common. The other could be a variable that's in common. You could have one of the two, or you could have both. It just depends on the problem. Now, it doesn't matter what kind of problem it is. This is what you do. The first thing you're going to do is you're going to look for the number in common. Okay, and those would be with the coefficients. And that you would be using your calculator for. And you would be pushing math, then you would be pushing the right, and then you would be hitting number 9. And just write this down for now because I'm going to do some examples in a little bit. After you look for the number in common, you look for the variable in common. Okay, once the variable is in common, okay, you now have your GCD or GCF, and you're going to divide. And then you'll have your answer. Okay, that is how you do GCD. Now, there's not always going to be a GCD. Sometimes you're going to have to move into the second step. How do I know I'm going to move into the second step? Okay, if GCD or F is 1 only, okay, and that means that there's not another number like a 2 or 3 or 4, or there's not a letter in common or a variable. Okay, move on. Okay, and that step would be called dots. And the dots stands for basically what you're going to do. First is difference, which means subtract. Then O stands for of. I'm not gonna write of. Okay, I'll do of 2 perfect. I shouldn't write that. 2. Just write 2. And 2 is, well, the number. It's going to mean that there are 2 terms. Okay, and then the third step is this S, which stands for perfect squares. Now, perfect squares are 1, the square root of 1 is 1, 4, 9, 16, 25, 36, blah, blah, blah. And if you don't know your perfect squares, you can always use your calculator to figure out if you have a perfect square. Now, if, again, similar to the other one, if you're still sitting at 1 from the GCD, okay, and nothing works, so you have no dots, you're going to move on to the trinomial. Now, I am, in this video, going to be a trinomial. Now, a trinomial is set up as ax squared, bx, and c, right? I am doing this video when the out value of a is 1. Now, when the value of a is 2 or so on, then that's when things could change a little bit, but I'm just going to be sticking to our basics right now, and that's when the value of a is 1. Now there's two ways to do a trinomial. One is going to be doing the calculator, and one is going to be doing it by hand. I will be showing you both. And basically step 1, now I have these letters here for a reason, you're going to multiply a times c, okay, and then you're going to get a value, and you're going to use the value of b. And basically, after you do this, you're going to get two numbers here. You're going to have a number from A and C, and you're going to have a number from B. You're going to have to try to find two numbers that would multiply to give you this value, and depending on if this was an adding or a subtracting, add or subtract those numbers to give you the B value. And then you'd be able to get your answer. And again, we're going to go over it. Go back to dots for a second. All dots questions, well, difference of two squares, are always going to be set up with two parentheses with a plus and a minus, okay? Or it could be a minus and a plus, just different signs. Okay, so all of your signs are going to be there. So there are all your notes. Now again, what I kept saying before why I love factoring is you follow these steps 100%, you're going to get somewhere with it. So just kind of have these steps memorized, follow these steps, and every question would be the same. All right, so let's dive right in. Okay, let's start with greatest common factor. So here I have a couple of scenarios here where I want you to find the greatest common factor, greatest common divisor of 36 and 12. Okay, some of us math geniuses will just know the answer, and if you're not a math genius, then you have a calculator, and it makes you look like one. Before I said to figure it out, what you're going to do is you're going to put that in your calculator. And this is why I call it GCD, because that's what the calculator calls it. And you're going to find the GCD of 36 and 12. So I'd come over to my calculator here. You're going to hit math, right, totally pushing right, nothing's happening, right, and then you're going to push number 9. Or you can go down to number 9 and hit enter. And you see it's GCD. And then you're going to put that in your calculator. 36, comma, here's your comma button right above 7, 12. And then close your parentheses, hit equals. So the GCD here is 12. That's how you do GCD, okay, from the coefficients. 16 and 64, same game. Math, right, 9. You would do 16, comma, 64. Close your parentheses, and your GCD is 16. So GCD of 16 and 64 is 16. All right, now, things get a little tricky when all of a sudden you start to introduce more than two numbers. The calculator can only do two numbers at a time. The calculator is only as smart as the person using it. So if you just try to go ahead and say to the calculator, tell me the GCD of 12, 8, and 36, the calculator is going to be like, well, sorry, I'm going to just tell you the GCD of 12 and 8 and forget that 36 was even there. So the way you kind of work around that a little bit, okay, is you do this. You say, all right, calculator, first find the GCD of 8 and 36. Then, after you get me that answer, GCD of 12. So basically, you're going to do GCD 2 times. Okay, GCD 12, comma, GCD 8, comma, 36. You want to put 2? Go ahead. Common mistakes, you forget this comma right there, so just make sure you take your time. All right, so I'll show you that one here. So math, right, 9, and you're going to do 12, comma, and you're going to repeat the process. Math, right, 9. So you see right here, 12, comma, and then there's that GCD again, and then it's going to be 8, comma, 36. You can close the parentheses, you don't have to, and then he would tell you your GCD is 4. You want to give a pause, try 10, 25, and 100. Maybe you're a math whiz, maybe you don't. Okay, maybe you just know the answer. Math, right, 9, 10, comma, math, right, 9, 25, comma, 100. GCD is 5. So that's GCD with numbers. Now some people are like, well, what if there's 4 and what if there's 5? Well, you just kind of keep playing the game. Just pretend for a second there were 4 numbers. Say I threw a 40 here. I would do GCD of 12. Then I would do GCD of 8. then I would do comma, and then I would do GCD of 36 and 40. So you just kind of keep GCD, GCD, GCD until you get to your last two numbers, depending on how many you have to find in your particular problem. All right, so that's how you're going to do it with all the numbers. Now let's go and look at variables. Okay, so here's how variables work. You find the variables that are the same. So in this case, there's two x's, right? This first monomial has x to the third, which means there are three x's. This second one has x to the fourth, which means there's four x's. And basically the question is saying, or a GCD is asking, just like those, what's in common? Greatest common divisor, or in this case it's the variable. So I would say, well, this guy has one, then you have one, and this guy can share one, and you can share one, and this guy has three. So we're basically sharing three. So then the GCD of x to the third and x to the fourth would be x to the third power. Okay. Next one. This one has 5 x's. The other one has 1 x. So how many can they share? 1. So the GC here is x to the first. You don't have to write 1, but you'd have to know that there is a 1 there. All right, now let's start going, well, what happens if there's more than one variable, like this one? We'll just take one variable at a time. This one has x to the sixth. Then the other one has x to the fourth. So if you take a 6 and a 4 and put them together, there are 4 that are in common. Okay. So in this case, it's x4. Now here you have y3. Here you have y1. The smallest exponent, okay, that's another way of looking at it, is 1. So the GCD between x to the 6th, y to the 3rd, x to the 4th, y to the 1st is x4, y1. All right. So just take your time with it. Again, when you're looking at it again, just say, what's the smallest variable exponent? So again, here's A, here's A. So here there are A3, here's A1. The smallest number between a 3 and a 1 is a 1. So I would say that they have an A1 in common. Here's a B2, there's a B1. So that means the smallest exponent is 1. Now, what happens if there's a letter all by itself with nobody to share with? Don't touch it. Leave them alone. There's your GCD. All right, so that is how you would find the number in common. That's how you find the variable in common. Now let's look at an actual problem where you'd have to use that. So here is what the directions would look like. Factor the expression. Okay, they're not going to tell you to do GCD a lot of the times. You have to know, and that's why you follow the steps. So if it says factor the expression, I start at step 1, part 1. It says find the number in common. So the number would be, what's the GCD between 20 and 12? Ignore negatives. Never put negative into your calculator. Math, write 9, 20, comma, 12. It's telling me the GCD is 4. So that covers step 1, number in common. Now, look at step 2. Do they have a variable in common? Well, in this term here, there's an x. This term here, there's a y. So they both don't have a letter, so GCD is 4. Now you go to step 3, which says to divide. So I'm going to divide my GCD. And now here's what the answer is going to look like. My GCD is 4. 20 divided by 4 is 5. Bring down the x. Negative 12 divided by 4 is negative 3. Bring down the y. We did it. We're done. All right. That's how you're doing these problems. Let's take a look at this one. GCD between 16 and 8. Again, ignore the negatives. Save time. 8. He has no variables. He does, so they don't share. So 8's my GCD. Divide. 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 Now let's write the answer. The GCD was 8. 16 divided by 8 is 2. 2. Negative 8 divided by positive 8 is negative 1. Bring down the x squared. That says 2 minus 1x squared. So right there, that's your answer. All right, so hopefully this is helping us. Here I gave you a couple of examples on how to do GCD when there are 3 terms. So here it's saying what's the GCD between 16, comma, GCD 8, comma, 24. Calculator will do 8. First term has x3, second term has x2, third term has no x's. So what number is in common between an x3, an x2, and then nothing? Well, there's nothing in common because they all must have the same variable. So I'm just going to be dealing with the 8. So I'm going to divide everyone by my GCD of 8. Then I'm going to get 2x to the third minus 1x squared plus 3. All right. Last one here, GCD of 2, 6, and 30 is 2. X, nothing, so your GCD is only going to be the 2. And then divide, I'm going to get 1x to the 6th minus 3x squared plus 15. So there you go. There is how you do GCD when you have a number in common. Now let's just take a quick look at a couple of examples here where I'm going to throw everything at you. So first one here says, well, what's the GCD of 6 and 19? So if I show you that here quick, 6 and 19, oh, I messed up. Oh, number 9, okay, of 6 and 19, it's going to say 1. So I'll write that. I'll say that the GCD is 1. Now, again, didn't look at we did look at them, but there was nothing there. He has an x2 and he has an x1. So what's the smallest exponent between a 2 and a 1? It's a 1. So here the GCD is going to be 1x1. 1x1. Okay, now what's step 3? Let's divide. 6 divided by 1 is 1. Now when I divide, you subtract exponents. So 2 minus 1 is 1. Negative 19 divided by 1 is negative 19. Now x1 divided by x1 cancels out, so you're left with nothing. So this is your answer. Okay, so rewind, watch it again, or watch me do the next one. Here says, what's the GCD of 3 and 10? Well, in this case, it was 1. Here has an x3. Here has an x1. So how many does a 3 and a 1 share? And they share 1. So my GCD is going to be x1. Here has a y2. Here has a y2. So how many do they share with 2 and 2? 2. So y2. That's your GCD. That's who you're going to divide. 3 divided by 1 is, oh, I got to write it first. 3 divided by 1 is 3. 3 minus 1 is 2. And 2 minus 2 is 0. Negative 10 divided by 1 is negative 10. 1 minus 1 is 0. 2 minus 2 is 0. We don't write 0, we just leave it alone, and there's your answer. All right, last one. Now we're going to combine every single thing we've learned here. So here we go. We got GCD of 8, 12, and 4. Again, don't put the negative. So that's going to give me a 4. There are 4 x's here, 2 x's there, and 1 x there. So the smallest exponent between 4, 2, and 1 is 1. There is 3 y's, 2 y's, and 1 y. So y1. And here there's a z, but there's nobody else that has a z. So I just leave the z alone. That's my GCD. That's who I have to divide everybody with. So 8 divided by 4 is 2. Remember, subtract your exponents. That's 3 minus, that's 2. And then again, put your z back. So 4 minus 1, and that's where I got the 3. 3 minus 1, that's where I got the 2. And now I have the z. Negative 12 divided by 4 is negative 3. 2 minus 1 is 1. 2 minus 1 is 1. 4 divided by 4 is negative 1 here. X's cancels. Y's cancels. There you go. Okay, So that's how you're going to go ahead and do all of their GCD questions. Okay, and that pretty much sums up most GCD questions that you could probably ever encounter. Now we go to the dots. How do you know that it's a dots? Here's how you know it's a dots. You start with step 1, question 1. Find the number in common. Find the variable in common. Divide. So again, it's just going to tell you to factor. So if I started here with GCD of 1 and 4, it's going to say 1. Now, do they both have a letter in common? No. So when it says GCD 1 by himself, that's how you know you're going to move to this dots question. All right. Now, dot stands for difference, which means subtraction. Do you have subtraction? Yes. Of 2, are there 2 terms? Here's 1. Here's 1. So yes, there are 2 terms. Now, do you have perfect squares? Okay. So again, can you find the square root of 4? Yes. That's going to be a 2. Now, for exponents, you just divide it by 2. All exponents, just divide by 2. Can you do 2 divided by 2? And you're going to say, yes, 2 divided by 2 is 1. Okay? This looks like, I don't know, like a math cat. See, I just saw it, and I just had to show you the world of math cat superhero. That's his symbol. Anyway, I digress. All right, so here's x1. Right there, I'm done. That's my answer. x2, x1, 2. That's your answer. If you're looking back at my steps here, okay, I had a difference. I had 2 terms. I had perfect squares. They always get set up with a plus and a minus, or a minus and a plus. Doesn't matter which I do. So if I put 2 parentheses, x2 is the answer. x2, x2. Mind blown, I'm done. Let's go to the next one. Oh, I messed up. See, I'm making this, and it's like, you get excited, and it's like, well, you just messed up, because then my whole theory of anything I'm trying to teach you right now isn't going to work. Let's change this to a 9. Can't do anything. Not letting me. Can't type. Can't do anything. This whole video is ruined. Can I type now? Come on. I'm dead in the water. Dead. It's okay. I can fix this. 9x4 minus 100 y6. Okay, there's that. Now I do magic. And it was never, ever there. All right, so here we go. Alrighty then. What is the GCD of 9 and 100? 1, because I made it that. What variable do they have in common? They don't. So when it's a GCD of 1 all by himself, we go to dots. Now we go through our checklist for dots. Do we have difference, subtraction? Yes. Do I have 2 terms? Yes, I do. Are these guys all perfect squares? Well, can you find the square root of 9? Now, again, if we're not math geniuses like myself here, we can always hit second x squared. That's the square root button, and then check your number. And it's, oh yeah, 3. Okay, so yeah, so I can do that one. That guy is 3 here. Can you find the square root of 100? Sure, it's 10. Anybody remember what you're supposed to do with exponents? Divide by 2. Can you do 4 divided by 2? Sure can. Can you do 6 divided by 2? Sure can. So it's 3x2, 10y3. That's the answer. 2 parentheses, 1 with a plus, 1 with a minus, or minus and plus. I don't care. So here's 3x2, 10y3. 3x2, 10y3. Bam. Done. All right. Here we go. There's no numbers. Well, that's fine. What's the GCD of 1 and 1? 1. Okay, there's an imaginary 1 there. They don't have a number in common, so it's not GCD. Okay, do we have difference? Yes, I do. Do I have 2 squares? Yes, I do. Is the square root of 1 a perfect number? Yes, it is. Can you do 2 divided by 2? Yes, you can. Can you do 4 divided by 2? Yes, you can. That's the answer, xy2. Make two parentheses, one with a minus, one with a plus. xy2. xy2. Okay, last one, try it yourself. Okay, I have difference. I have two terms. The square root of 100 is 10. 2 divided by 2 is 1. So 10x is the answer. Now, some of you are going to be saying, well, does the order matter? Yes, 100% it matters. So the 100 came first. The 10 comes first. You better write it first. You can't write it the other way around. All right, pause it. Try the last one all by yourself. Nice, easy one. X squared plus 36. Did you do it? Did you get x plus 6, x minus 6? Well, probably not, because the odds of you actually pausing it and trying on your own are about 5%, 4% maybe. But if you did, you got it wrong. Because, again, all right, let's start it. GCD of 1 and 36, 1. No variable in common, so I move on to dots, right? Do I have difference? Difference stands for subtraction. No, I don't. I don't have difference. So you can't do this. You stop right there. Okay? Once you answer no to something here, you got to move on to the trinomial. Okay? So here you're going to write, some people like to say that the answer is prime, or some people like to say that you cannot factor it. Okay? That's how you'd stop right there if you had a plus instead of a minus. You can't do it. And now we move on to the trinomial. And like I said, we have two ways of doing it. One is by hand. The other is by using your calculator. And I'll show you them real quick here. All right, now, again, why it's my favorite, follow your steps. So step number 1 is, do I have a GCD between 1, 7, and 12? Sure, I do. It's 1. Okay. Is there a variable in common? No, because they all don't have the x, so you move on to dots. I have difference, and you have to have how many terms? 2, but I have 3 terms. That's why this is a trinomial question. And that's when you're going to move on to the trinomial step. All right, so here's how I show trinomial if you're doing it by hand. And it works for pretty much all of them, right? So you multiply the first number times the last number. So I multiply 1 times 12, and it's 12. You take the last sign, which is a positive, and then the middle number, which is a 7. Now you have to find two numbers that multiply for 12 and add for 7. So there's a small shortcut for that. If you take that 12, or that multiply number, and divide it by x, and then if you went to the table, these are all of the numbers that multiply to give you 12. 1 times 12, 2 times 6, 3 times 4. Now, again, because it was a plus here, which can you choose that would add to give you 7? Is 1 plus 12, is 2 plus 6, is 3 plus, there it is. 3 plus 4, 4 plus 3 gives us 7. So I know that my two numbers are going to be 3 and 4. Now, what you do is the larger of those two numbers gets this sign, always. Then you say, okay, you know that the 4 is a negative. Do you add 3 to the 4? Or do you subtract 3? Well, it was a minus 3. So that means that that's a minus. So the answer is x minus 3, x minus 4. This is showing all your work and doing it by hand. Shortcut to that is if you went here and just put the problem in, right? X squared minus 7x plus 12 and hit graph, you're going to see the quadratic, right? And if you notice, it's going to hit the x-axis. It could be in one spot, it could be in two spots. And those are called roots or zeros or solutions. And you can also find them in the table where the y value is 0. And you can see one of those spots is when x was equal to 3, and then the other spot is when x is equal to 4. Then all you have to do is change its sign. So I change the 4 to a negative, 3 to a negative, and it ends up with the same answer. So those are your two ways to do a trinomial. I'll do the second one. I'll do it backwards. First I'll do the calculator, then I'll do it by hand. So this one says to factor x squared plus 2x minus 15. So again, if I'm following my awesome steps that I gave you, because when you take the test, it's not going to tell you which method to use. The GCD of 1, 2, and negative 15 or positive 15 in my calculator is 1. No variable in common. So now we're going over to dots, okay? And it's not a dots because there are 3 terms. So we're gonna, now we know that for a fact that you're going into a trinomial. So I'm gonna go over here, x squared plus 2x minus 15, hit graph, there it is there. If I count, you can see it hit right there at negative 5. It looks like it hit right there at positive 3. Remember, if you go to the table, look at the 3, it was 0. At the negative 5, it was 0. Then remember, what are you supposed to do here? You're supposed to change their signs. And there you go. That's doing it with the calculator. You don't have to show work there. This is kind of like showing your work. Now, how are you going to do it by hand? Okay. Multiply the first number times the last number. So 1 times 15 is 15. Forget the signs. The middle number, again, forget the signs, is 2. And you just take this sign, which is a minus now. So now I need to figure out what are 2 numbers that multiply for 15 and subtract for 2. Okay, for our non-math whizzes out there, we can always do 15 divided by x. Now, oh boy, don't look at that. Don't look at that. Go to the table. Which 2 numbers, if I picked from here, 1 and 15, forget that, 3 and 5, would I subtract and get 2? And that would be 5 and 3, right? So then the bigger number gets the sign, and 5 minus 3 equals 2. All right, if you want to try this guy by yourself, go for it. Otherwise, I'll just do it here. If I'm using my calculator, either way, doesn't matter. X squared minus 12x minus 60. Graph, you'll see, boom, it hits there. Notice you don't see the other side. That's because it's a really big number. Or it's a number outside the window. So you'd have to kind of look around for where it hit in that particular spot. So you'll see one of the numbers here, it was at that's why that should be an 11. I did terrible math there. Should have probably checked this over before I did it with you guys. That's okay. 1. Watch this. Watch the magic. I was trying to do 15. Oh, there it is. See, it's 4. And then right down here at 15. There it is there. If I'm doing it by hand, right? 2 numbers that multiply for 60 and subtract to give you 11. And that's going to be 15 and 4. Minus here, plus there. And then again, if you were doing it by here, one of the answers was 15, you change its sign. One of the answers was negative 4, you change its sign. All right, almost there. Last one. Now, I purposely put this one, okay, just to make sure that people didn't get too confused. What are 2 numbers that multiply for 6 and subtracts for 1? Pretty easy, 6 times 1. Okay, don't forget that 1 you can use that one. So you're going to have a -6 and a +1 would give you that. All right, so there's your factoring. There's my favorite. That's everything. Again, there gets to be some more in-depth things from here, but if you're following these steps, almost most of the factoring questions you're ever going to see will be able to solve by this. So hopefully you guys enjoyed the video. Leave your comment, like, subscribe, all that cool fun stuff.